Hi, just a quick video here. I've got this 2014 VW Transporter in the workshop today. The guy who booked it in called it the unfixable van. He's had it 3 different garages. Nobody's managed to actually get to the bottom of the problem. I just have. So I'm just going to walk you through the process I took. When the vehicle came into us, first thing I did was using VCDS. I scanned the vehicle for faults, and we found 7 different faults in the vehicle. Manifold barometric pressure sensor, G71, implausible signal, particulate trap, efficiency threshold below efficiency below threshold, P2002, boost pressure regulation limit exceeded, overboost condition, manifold barometric pressure sensor G71 malfunction, manifold barometric pressure sensor G71 signal too low, manifold boost pressure sensor signal too high. As you can see, I've saved the faults, I printed them, and then I cleared them, and the only fault that came back was this one here, which was manifold barometric pressure sensor implausible signal. So the G71 sensor on this vehicle is actually built into the intake air pipe just in front of the just upstream of the air mass meter. I'll show you it now. This is it here. It basically measures the pressure in this pipe between the air filter and the turbocharger intake. It's a 3-wire sensor, as you can see, works on a 5-volt reference circuit. So the first thing I did was check the live data for this sensor and found that the live data looked plausible. It was sitting at 1000 millibar or thereabouts, which is atmospheric pressure. I won't take live data as read because it is actually processed data. So I then went on to test the sensor itself, and I'll show you how I did that. I'm using today the N2 Neuron. It's basically a Bluetooth multimeter. You get an app which goes on either an Android or an iOS tablet or phone. This one was supplied by Alex Gilbanks of Impact Diagnostics. Thanks, Alex. And it's proved to be invaluable, to be fair. It's a great versatile tool. You're not tied to a job by your multimeter, whereas if you were testing wiring, say at the back of a vehicle and you were in the cab, cycling ignition or switching a switch, you would need very, very long leads to get that multimeter into the cab with you. With this, you just leave the little black box next to the connection and bring the Bluetooth tablet to where you want to actually monitor the voltage or whatever. So anyway, we're looking at the bottom figure here, the one that's sitting at 0 volts at the minute, and we are back probed into one of the pins on this manifold pressure sensor. So we're on the blue pin at the minute. I'm just going to touch that there, and as you can see, I've got 37.37 millivolts. Now at this point, I didn't know what I'm going to be getting, so next I'm going to go into the outer one there and check that, and I've got 0 volts on that one. What I'm going to do is I'm going to find out which one of these is a ground, so I'm going to go off the ground and go onto the power and check that there. And as you can see, I've got minus 1.13 volts, so that's my sensor ground circuit. I'm going to go back onto the ground side and now check the last pin. So on the yellow now, touching that one, and 37 millivolts similar to the blue. So straight away, that rang alarm bells. what I'm expecting to see is, I'm expecting to see 5 volts on one of these pins, I'm expecting to see a ground which I've got on another pin, and I'm expecting to see a unspecified voltage at the minute, which would be the signal wire on the other pin. So definitely got a problem with this circuit. So next thing is to check the wiring diagram. There's the wiring diagram for this particular circuit. I'm using all data. The reason I use all data, it's actually manufacturer diagrams. It's not another company converting the wiring diagrams into their format. It's actually the wiring diagrams as they would appear on the manufacturer's technical sites. So what do we have here? Just get something to point with. This component here is the manifold pressure sensor. As you can see, we've got the yellow wire, we've got the brown and green, and we've got the blue. The blue comes from the engine ECU, which is this up here. The yellow wire goes down to this black line. This black line here is actually a splice in the wiring harness, and the brown and green goes down to a different splice in the harness here. As you can see, only one of the wires on this circuit is independent, which that one will be the signal wire. The yellow should be the 5 volt reference, because we've already established that the brown and green is the ground. So the 5 volt reference is shared by this component here, and this component here, and this component here. When we look at the key for the diagram, this component here is the DPF pressure sensor, and this component, this one here, is DPF pressure sensor as well, but for a 4x4 vehicle, so there must be a difference in the diagram. This component here is the neutral position sensor switch. So all three of those components share a 5 volt reference circuit and also share the same ground. We've established that the ground at this component was good, so it's this 5 volt reference circuit which is the concern. Now we've got faults for DPF, which was P2002, which was efficiency below threshold. So next thing to look at would be the live data for this sensor here. I haven't got the live data up at the minute, but I did check the live data, and basically the figure I was seeing was implausible. With the key on engine off, it was sitting at around about, I think it was about 80 millibars. So it should be 0. So let's take a look at this pressure sensor. This is the pressure sensor here. Now, as you can see, that's not an original VW item. I would assume that one of the previous garages have replaced this based on a fault code. And as you know, I don't agree with changing components based on fault codes, and I also don't agree with fitting on genuine parts either. So at this point, it sort of rang alarm bells. I'm thinking, is this sensor pulling down my 5 volt reference circuit? Could it be an actual bad sensor, a poor quality sensor? So the next thing I did was unplug that to take it off circuit, and then went back to the yellow terminal on here and check this voltage again. And as you can see, it's still at 37 millivolts. So the sensor isn't at fault at the minute. We've still got low voltage on the 5 volt reference. So next thing was to unplug this. So taking that sensor off circuit as well, and then checking the voltage once again. So with the sensor unplugged, with that sensor unplugged, I've now got 0 volts on that wire, which makes me think, is this a pull up sensor, meaning that it pulls the voltage up from ground rather than pulling the voltage down from 5 volts. So to test that quite easily, again, just remove the other end of the multimeter from the ground side and put it onto the power side. So we're on the power side now, and we've still got 0 volts. So it's not connected to anything. It's not connected to a power source, it's not connected to a ground source. So with that in mind, we go back, put that back onto the ground, and we check the last terminal again, which is the blue. So I'm now back probed into the blue, and I've got 5.73 volts. So as we established before, the blue is the signal wire. So what that tells me is this sensor is a pull down sensor. It basically, when it's connected, when the circuit is intact and connected to the component will pull that voltage down from 5 volts, and depending upon the pressure applied across that component, that voltage will vary. So we're still looking at an issue with the yellow wire here, which is our 5 volt feed. Now that should be 5 volts whether the component is plugged in or unplugged. In the back of the yellow wire again, and as you can see, I've got 0 volts, meaning that I've got nothing on that circuit. And if I take the other side of my multimeter and put it to battery positive, I've still got 0 volts. So that wire would appear to be unconnected. I do the same test at the differential pressure sensor plug. I'm on the yellow and black wire, which, as we saw in the diagram, is the 5 volt reference to that component. There we go there, yellow and black. I've got 0 volts there as well. So exactly the same at this component here. So back to the diagram. As you can see, the 5 volt reference comes out the engine ECU on a black and yellow wire here. It goes to this black line here, which is a splice in the wiring harness, and then it splits into 2 or 3 depending on if it's got a neutral position sensor on the gearbox. This vehicle doesn't, so we can kind of ignore that side of the diagram. So it'll come to a splice, which will then split off into 2, one with a yellow wire, one with a yellow and black wire. So we need to find that splice. So I checked with the technical information and found that that splice is actually in there. This is the electrical center that's in the engine bay of this vehicle. It's the battery would normally sit on top of here. This is kind of where the headlight would be round here. Very difficult to access. The engine ECU, which is hanging down here, would normally be sort of slotted down into there. So I identified which pin on the engine ECU this wire came out of, and it comes out of the larger of the 2 plugs, this one here. And what I did was I tested, I'm going to test the voltage actually coming out the engine ECU, and to see if I've got my 5 volt reference being transmitted from the engine ECU. So I'm now back probed into the correct pin on the engine ECU, which is there. And as you can see, I've got 5 volts coming out the engine ECU. So once again, going back to the diagram, so this wire here, I've got 5 volts. So I now need to identify where this splice is and test basically this side of the splice and this side of the splice to see if I've got 5 volts on the other side of the splice. This is the splice here. We've got 2 wires on one side of it and 1 wire on the other. We've got a yellow and black on this side. That yellow and black actually goes to the differential pressure sensor. It goes out to the side of the fuse box here, goes into the engine bay and goes up onto that pressure sensor over there. We've got 2 wires on this side. We've got the black and yellow coming from the engine ECU, which I'm connected to at the minute with this side probe, and we've got the yellow wire which goes to the manifold pressure sensor, which then goes out of the fuse box back here and goes up through the main harness along the bulkhead and ultimately goes over to the sensor over there on that side of the splice. So as I say, I'm probed into the black and yellow from the engine ECU to the splice to check to see that I have got 5 volts at that point in the harness, to verify if it's the splice that's the issue. And oh, my tablet's just gone off. And as you can see, I've got 5 volts there. So I know that the wire is good from the engine ECU up to that splice. So what I'm going to do is I'm going to take that probe off that wire, and I'm going to stick it on the wire next to it, which is the yellow wire which goes to the manifold pressure sensor. And as you can see, I've got no volts there. So it's looking like a bad splice here. And then I'm going to go onto the other side there, which is the wire that goes to the differential pressure sensor. And I've got a small residual voltage of 21 millivolts there. So basically, I've identified that I'm losing my voltage through this splice somewhere. So I'm going to cut the splice out of the harness. I'm going to re-splice these wires, but I'm going to actually cut this splice open to have a look inside of it, see if we can see anything. There we have it. Splice has been replaced here. I've replaced it with this crimped heat stringed connector, which will be basically as good or hopefully better than the factory splice. I'm just going to test this splice now. So I've got the top measurement here on an ohms resistance test, and there's the splice. What I'm going to do is I'm going to connect across the splice and see what the resistance is in the splice. We should be seeing 0. And there I am, connected across the splice. It's still saying out of range, which means open circuit. Now, just to prove the plausibility of the meter, I'm going to connect the crocodile clips together. I've got the croc clips connected, 0 resistance. So this splice is iffy, so I'm going to split it open and have a look at it. As you can see, what I normally see with broken wires, you normally see green crusties on them, but there's nothing to really be seen on this thing. Visually, if I inspected it, I would say that looks like a good splice, but it's clearly not. So I'm going to cut it open and have a look. There we go. Ultimate proof that this splice is the issue here. It's just obviously absorbed some water and rotted. So not good. Now basically, to get to that, to fix that, as you can see, I've got this van quite dismantled just to access the area of the wiring harness. I've got the slam panel there, headlight, battery. I've got the intercooler, bits of bumper and what have you down here, just to get into this box to get to that splice, which basically lives in this harness, and then its back in place is right in the bottom of this box. So yeah, a bit of, you know, for the sake of a no parts fix, but a bit of time has been spent to get here. So I'm going to build this back up. I'll obviously be retesting the circuits along the way, but I'm 100% sure they're going to be okay. And then I'll sum up when it's back together. So just before I put the front back on this van, got the battery connected up, got all the wiring connected back up inside the fuse box. I'm back probed on that yellow wire, as you see, and I've got 5 volts. So if we plug that in, that should stay at 5 volts, which it does. And then our blue wire, being the signal wire, should give us a voltage, 4 volts. And basically, as the pressure drops within that tube, so will that pressure. And then we'll just check on the differential pressure sensor. We've got the same. Plug that back in, still retain more voltage. And pin 1, I believe. There's our 5 volts. And the signal wire, which is pin 3, 1 volt. Perfect. So I'm going to build this van up. I'm going to give it a road test and make sure none of these faults reoccur. So we've now got cleared the faults. That's the 2 values that we were looking at. The 2 sensors we're looking at, the particulate filter differential pressure sensor, and also the air cleaner, the pressure upstream of the air cleaner. As you can see, that's sitting around about atmospheric pressure. The differential pressure is -1 HP. It's near enough 0. I started up. We've got 2 HPA at differential pressure, which is 2 millibar, which is next to nothing, and the intake air pressure after the air cleaner is still sitting at around about atmosphere. If I give that a rev, see the differential pressure rises a bit and the air pressure sensor after the air cleaner goes down a bit, so basically showing that it's drawing air through the air cleaner. So no warning lights on the dashboard. Before the van came in with an engine light on, and the guy was saying that nobody's been able to get rid of that engine light. It's always been on, so basically down to that rotten splice. So I'm now going to road test the vehicle and just check out it is actually okay. There we go, road test complete. As I say, it came in with an engine light on, and the guy actually said when he drives it and puts it under load, the glow plug light would flash as well. It's drove fine, no warning lights at all. So I'm going to call this one a fix. So if you have problems with your vehicle and you want a first time fix, give us a ring. I won't just fit parts based on fault codes, which has been what's happening with this vehicle, or just clear the faults and send it on its way. Sort of stand there scratching my head, scratching my backside and saying I don't know what's wrong with it. We'll get to the bottom of it. Key to this is basically understanding the fault, understanding the system that you're testing. If you understand the circuitry, understand how it works, then you can basically drill down and find out what the underlying cause is, which in this particular case was just a corroded splice in a wiring harness. Obviously the labour time for this one was quite high because of the amount of strip down required to get to that part of the harness, but anyway, it's sorted now. I'm going to ring the guy up, get him to pick his van up, and he can get back to work. Thanks for watching. If you've got any issues, as I say, give us a call.